हमारा स्कूल का पोर्शन बोर्ड के करवा के ले लो। एल्यूमिनियम को देखने को लगता है एल्यूमिनियम एल्यूमिनियम सोडियम एल्यूमिनियम एल्यूमिनियम को सब काम एल्यूमिनियम क्या बोलते हैं हार्ड को एनएच ना अरे मेरा जिस नंबर को मैंने केमिस्ट्री में ये सब लिखा था वो मेरी केमिस्ट्री में लिखा है कैसे अंदर के इलेक्ट्रॉन लॉस है ये इलेक्ट्रॉन लॉस है सिर्फ चूज करने का याद रखने का Na3ALO3 क्या है चलो गूगल करते हैं कि नाम को फेक के बोल रैंडम अगर ट्राइसोडियम एल्यूमिनियम को सोडियम को सोडियम मेटा एलिमेंट तुम्हें उसने चाहिए था क्या है अरे मैं सही था गूगल को आई बस पार्ट नंबर 104 हैप्पी बर्थडे करो ये बस नहीं सोडियम मेटा एलिमेंट मेटा पोटेशियम मेटा There are other bloodlines in the जब एसी और मेरा बता so many इसमें decompose एसी और पहले हो गया नहीं sure so then we are on the exam चल रहा है ना after birth so they will miss this topic even the previous one last वाले part में तो वो लोग नहीं लिखा मैंने उसका नाम निकाला इसका नाम निकाला तो Na3ALO3 और K अच्छा वो अलाइन वाला और वो आपका टेक्स्ट लेकर आया तो पिक्चर दिखाके हां वो लैपटॉप में हां दिखा so even here I this symbols उनको सिर्फ याद रखने नहीं बोला है हाँ याद रखने नहीं बोलता लेकिन वो सब इधर ऊपर ऐसे हाँ इसमें तो एक ही पार्ट दिया है ना यहाँ पे पेंसिल से दिए हैं जैसे ऐसा बता दिया है ना but for example this is your then thoughts like when they deviate computing that there will be one statement to the specific those of them who say this is maximum they are passing 1 2 3 4 5 how we are able to 1 2 3 4 5 okay you are deflated at 1, 2, yeah, which other way. They could serve deflated and very few are response. समझ में आया? तो डिस्कस होगी because of this cosmic change. वैसे easy है, वो पिक्चर वैसे कॉम्प्लिकेट करना है, otherwise it is easy. चलो, I think last step should have completed with that one. First, I don't know. मैं सही था, वो सोडियम मेटल मैंने नहीं था. Na3 page 104. सही गलत का बात नहीं, क्या मतलब है, वहाँ पे वैल्यूज अलग जा रहे हैं और वॉल्यूम में वैल्यूज अलग जाते हैं. And even one more thing I have seen in the tension book, reaction was different. It is given everywhere that reaction is given, but in the explanation part, other reactions. इसलिए पूरा आपका टेक्स्ट बुक का रेफरेंस ले लो और आगे को रेफर करो. पेज नंबर ये वाला आप जो बता रहे हैं ना 104 104 है, नोट डाउन करके रखूंगी. 104 कौन सा वाला? लास्ट वाला एल्यूमिनियम, वो टेबल है ना, उसका लास्ट एल्यूमिनियम पार्ट है. प्रोडक्ट साइड में सॉल्ट KaO2 और Al3AO. हाँ, क्या है? फर्स्ट वाला 2Na3Al3 सोडियम मेटा एल्यूमिनेट और लास्ट वाला पोटेशियम एल्यूमिनेट. सोडियम मेटा एल्यूमिनेट कहाँ से निकाला ये नाम बताओ? टेक्स्ट बुक से निकाला है कि गूगल बाकी है? गूगल. गूगल वाले पापा कंप्यूटर डर लगता है because every time Google and AI करते हो. क्या वो आपने कर रहे हो अभी? AI चल ठीक है. It is not correct. नहीं, it is happening. No, I'm not lying. ऐसे करके IUPAC नेम से मैंने बहुत सारा देखा है. Actual structure is given and it is giving something different. So इससे मैंने नाम देखना छोड़ दिया. नहीं है. I think last time we have completed this study of first element, hydrogen. We have discussed what is meaning of oxidation, reduction in terms of electrons and in terms of oxygen as well as hydrogen. फटाफट एक से recap करके लेते हैं. Then we will start with the new topic. Oxidation and reduction. अगर कोई आए 5-10 minutes में तो ठीक है. Otherwise, we will start with the. Okay, so you can define oxidation and reduction in two terms. First is with respect to electron and second with respect to oxygen and hydrogen. Right now, Shanti, Choti Shanti, Badi Shanti लेते हैं. Okay, so with respect to electron, what is oxidation? Minus E into. Okay, on this side, contrast one you have to give. This side, it is gain of E. Okay, one thing we have done. So reaction in which order it is a metal ion which loses an electron to get converted into. No, कुछ भी इलेक्ट्रॉन रिमूव करो और ऑक्साइड में कन्वर्ट करो. हाउ इज इट पॉसिबल? शांति, पूरी अशांति हो गया. वेरी बैड. Metal ion, if it is Na, it will be converted into. तो उसको क्या बोल रहे हैं? We are saying electropositive ना. Electropositive ion is obtained on that side. Here it will be formation of electropositive positive ion. On this side, formation of electronegative negative ion. So negative ion. This positive ion it is known as positive ion. It is known as cation. It is known as cation, and this is known as C. It is known as anion. Okay. Then the atom ion on the species which is undergoing oxidation. It is acting as a which agent? reduction agent. It is acting as a reducing agent. Remember, oxidation, reducing agent. Ulta. Whereas here you have reduction, this will be acting as an oxidizing agent. So this many points you can give. There is no problem. Very simple, very easy to remember. If you know the meaning oxidation and reduction, you can easily complete the remaining part. Okay, moving next to this one, second type. Second type in terms of oxygen and reduction. Oh, sorry, oxygen and hydrogen. Oxidation is what? Addition of oxygen. Addition of oxygen. Removal of hydrogen. Or don't forget this or. Both things are not happening. Any one, it is or minus H. That's it. Plus O. Oh, sorry, it is plus H or minus O. बराबर है. So here you are adding oxygen or you are removing hydrogen. On that side you are adding hydrogen or you are removing oxygen. So here it is addition of electronegative atom. Oxygen it is being electronegative. It is addition of electronegative or removal of electropositive. ये भूलना नहीं हाँ. Oxygen it is negative and hydrogen it is positive. So what we are doing here, we are doing addition of electronegative. हाँ चलिए तो note down करके रखो. Addition of electronegative or removal of electropositive. On that side, what we are doing here, we are doing addition of electropositive and removing electronegative. Remaining part oxidizing agent, reducing agent, it will remain the same. चलेगा ना? कोई दिक्कत नहीं ना? You can easily do ना? So they make you to define, to identify. Define करना, it is very easy. To identify, first you have to check whether that given reaction it is in terms of electron or in terms of oxygen and hydrogen. But if this concept is clear, you can easily do. Okay, in same way it is given on page number last वाला page है हाँ. One small table is given. देखो whichever point we have written, they are correct or not. Check करो addition of electronegative correct. हाँ removal of electropositive correct. On that side addition of electropositive right. Removal of electronegative that also done. Then increase in the positive valency. ये वाला point रहेगा. Increase in the valency. Okay. ये वाला मैं आपको बता देती हूँ. तो पूरी चीज क्लियर हो जाएगी with respect to valency. So here I have given you example Na giving Na positive plus 1 electron. यहाँ पे ध्यान दो हाँ reaction में whereas Cl plus 1 electron it is forming Cl negative. Now this is a neutral atom. This is a neutral atom. We are converting it into cation. बराबर है ना? We are converting it into cation. Neutral atom contain valency 0. अब ये 0 वाला क्यों बोल रहे हम लोग? 0 एटम रहे न्यूट्रल स्टेट में 0 बता रहे. नॉर्मली फॉर सोडियम इट इज +1. वी नो ना इट इज +1. तो from here to here we are losing 1 electron, we are removing 1 electron, so oxidation state becomes here plus 1 electron remove, oxidation state +1. Okay, so abhi for this one here it is neutral atom, we are taking 1 electron. Cl, in Cl there is addition of 1 electron. Cl it is converted into Cl negative from 0 to minus. If you have this number lines here, 0 here, positive here, negative here. Now look this two example. Observe this two example carefully. This is our normal number line.
which we use for making graphing, mass or quadrant. Okay, now tell me in this two, for which side there is an increase in the oxidation number or decrease in the oxidation? From 0 to 1, this is from 1 to -1. यहाँ पे कुछ न्यूट्रल एटम में it is 0. हाँ सॉरी, one neutral atom it is 0, 0 to -1. बता दो. On which side there is an increase in the oxidation number? This side, that side? ये साइड में, तो वो साइड में क्या है? From zero, if you add 1, it will go in 1. But actually we are removing electron. We are changing it from 0 to plus. Okay, from 0 for exploring, from 0 we are going on the negative side. कम कर रहे, माइनस कर रहे, तो ऑक्सीडेशन नंबर कहाँ बढ़ रहा है? रिडक्शन. देखो यहाँ पे मैंने एक बढ़ा दिया, यहाँ पे मैंने एक कम कर दिया, कहाँ बढ़ गया ऑक्सीडेशन नंबर? From 0 I have shifted to +1. आराम से, शांति से, हाँ ज्यादा एकदम दिमाग में मत बिठाना. From 0, 1 boy are having 1 class center वगैरह नहीं बताने वाली. Now here what we are doing? We are adding 1 electron. But term used is reduction. Normally when we are using reduced term, when we are removing, बराबर है ना? तो वो मुझे बोल रहे हैं मैम ये रिडक्शन है. ये reduction है, we are giving name reduction. Then why we are adding plus electrons here? It should be another name, addition reaction. Oxidation नाम होना चाहिए. तो उसको बहुत समझा के बताना पड़ा कि भाई reduction in the sense what we are doing, we are going from 0 to negative side. We are removing, we are reducing the oxidation state. बराबर है ना? अब यहाँ पे देखो from 0 by addition we are moving to right hand side. We are adding. Okay, adding oxidation number बढ़ रहा है. ये oxidation number जो है it is increasing. Okay, no matter whether 1 electron is lost, 2 electron is lost, वो नहीं, but we are increasing the oxidation number. Whereas in case of this one from 0 to -1, what we are doing? We are decreasing the oxidation. Oxidation number को please don't link with the valency. Okay, because oxidation number it is a value, it is a numerical value which is obtained by gain or loss of the electron. और valency क्या रहता है हमारा? Number of electrons in the outermost shell in order to complete the octet. बराबर है ना? Done now. So this part is clear to you. So one more point you can add here. In oxidation reaction, there is an increase in the oxidation number, whereas in the reduction reaction, there is a decrease in the oxidation number. If you want, you can take down this example. It is not given in your book. You can note it down. Oxidation, देखो increase in the negative valency. समझ में आया? Decrease in positive valency and next point increase in the negative valency. So you can go with any one of the point. Both things are correct. मैंने आपको दिया है for oxidation there is an increase in the oxidation number. For reduction there is decrease in the oxidation number. So done, understood. So if the reaction is given, first identify it is of which type with respect to electron or with respect to oxygen or hydrogen. According to that, you can work on that particular reaction. Done. So let us start with a new topic. So our new topic is topic number 7, state of gas, study of gas loss. Hello. Hello. अच्छा खाने में अंदर पहुंच जाता है नहीं मेरा रूम तो नहीं चाहिए मेरा रोड से जाने के लिए 2-3 घंटे छोड़ मेरा रोड माटुंगा देखे ना माटुंगा चाहिए नहीं वो भी बहुत कभी मैं भी कर तो वो माटुंगा चेंबूर माटुंगा बस चल मैं रखती हूँ पास वाले दिन योगेश्वरी की रोड से ओके अल्लाह हाफिज़ मैम थैंक यू Only those students are going to the rest students, I guess, they have a school exam and that normal party is having some body. So after your 10th standard, 12th standard, whatever you want to do now, what is your goal, decide your goal, work out according to that and try to appear for all the entrance exam. Don't skip maths in class 12, no matter it is difficult. Okay, Nate, this is a normal, even bio. So for your 11th and 12th, you take both the subject maths and bio. Okay, जिसमें इंटरेस्ट है वो ज्यादा करो जो दूसरा सब्जेक्ट है ना फॉर एग्जांपल फर्स्ट स्टूडेंट मोस्टली दे skip maths they go for bio but it may happen that you will not score good in so that time there will be no option अगर आपका maths है you can also go for computer science और उसमें आगे और एक चीज बताना मुझे बहुत बेटर लगता है so if you are going for NEET तो ऐसे भी करते हैं बच्चे to after 12 they take one drop to have good score in it but every time wonder is not happening ना जैसे एक साल 2 साल पहले हो गया था most of the student they score 720 or 720 so this is also possible in case this is happening कि अगर आपको ड्रॉप लेना है then you can work with plan समझ में है ना कि ऐसी बहुत सारी चीजें हैं where need is not there it is also part of medicine समझ में आया ये मैम अभी से क्यों पता है क्योंकि मैंने बहुत से बच्चे ऐसे देखे हैं even boy students they are taking drop for 4-5 years तो unnecessarily it is waste of time चलो anyways वो हमारा टॉपिक नहीं है बट आपको भी पता चाहिए आगे क्या क्या होता है आपको कौन बताने वाला रहते बहुत है लेकिन आपको सेल्फ गाइडेंस कोई नहीं देता स्टडी टॉपिक का नाम लिख के लो स्टडी ऑफ गैस लॉ के गैसेस है गैस गैस this is our topic number 7 now study of gas law itself this topic is very important same topic was there in class 11 but during COVID time it was deleted and still it is not added but for entrance exam you have this topic okay तो उसका जो basic जो भी कुछ part है that we need to focus now in order to study for the gases first we will see what is meaning of matter then we will go for the states of matter and then properties because this thing should be clear to you otherwise बहुत बड़ा है और धीरे से जाएंगे क्योंकि अभी ये लोग तो शायद नहीं आ रहे ओके सो मैटर define matter space anything which has mass and that occupies space so it may be anything this mouse this keyboard marker book kuch bhi anything matter around us this all are matter all are having mass and they are occupying space so matter thing it is clear then states of matter as per your syllabus I think 3 states are given तीन ही है ना, but one more state is added. Actually 5 state है total. From that we have 3 in our syllabus, plasma state and one more Einstein state भी दिया हुआ है. So we will not go for that particular part. We will only go with the 3 states of matter. 3 states. कौन से हैं? Solid, liquid and gas. Okay. 3 states: solid, liquid and the gas. Okay. Now properties. Properties. So for example, here I have solid. This is the liquid compound and this is the gas. तीनों को भी मैंने I have placed all three in a cube, solid, liquid as well as. So what are the properties of this three state? If you have example, normal example, we will go with the water in all three state. आपको तो पता है ना कौन से state में? The solid state of water is
ice,
liquid state
water,
normal water, and gaseous state water vapors, or steam water vapors. Okay, चलो बता दो मुझे इसमें क्या difference है? Properties कौन से? Due to which chemically all these three state, chemically it is H2O. Physically they are different. Okay, how physically they are different? चलो बता दो.
solid state of water में negligible intermolecular space और water के particles हैं.
Negligible solid के negligible intermolecular space. अच्छा, आगे जाने दो. आगे, हाँ, आगे, बराबर सही.
Strong force of attraction between molecules.
So if this is a molecule, brush okay. If this is one molecule, this is another molecule. Here one more molecule, here one more molecule. This will go in same pattern. Okay. Next one. हाँ.
Intermolecular force of attraction is less than solid,
हाँ.
but more than gas.
More than gas. So this means molecules are little bit away.
Space is large.
Space is large. Due to large space, intermolecular forces of attraction, they become less. Then third one.
Intermolecular space is the largest. Intermolecular force of attraction is very weak.
तीन ही बनाए मैंने. हाँ, जगह नहीं है अभी बनाने के लिए वहाँ पे, because इससे भी ज्यादा उसमें रहेगा. Okay, if we have perfume bottle here, यहाँ पे खोला है, जैसे कि अभी perfume क्यों, ये जो smell आ रहा है, it is coming from, I think it is coming from outside. दरवाजा बंद किया है वेंटिलेशन के रूप में नहीं, बट अब तो स्मेल नहीं है ना, पता नहीं कहीं से तो आ रहा था वो स्मेल, तो गैस वाली. Now here, in case of solid, molecules are closely packed each other. So due to this, what happened? The force of attraction is more. They are closely packed. Okay. Here molecules are little bit away, more away as compared to solid, less away as compared to gases. Okay, so what happened? As compared to solid, the forces of attraction here, they are less because molecules are away from each other. But in this case, they are far away. So what happened? The forces of attraction, they are almost negligible. One point. Another point, state, it is only the result of this intermolecular forces of attraction. Okay, so the solid compound, they have fixed, rigid shape
And volume.
as well as volume. हमको आइस बनाना है different shape का. Okay, so according to the required shape, we use that tray. In tray various shapes are present. Normally jelly के लिए हम लोग वैसा वाला use करते हैं. बराबर है ना? If you are making cake, then different shapes are used. So here what happened? They are rigid and they have fixed shape, fixed volume. In case of liquid, molecules are वैसे ढीला ढाला रहते हैं वो लोग. So they take the shape of the container. Okay, shape of the container. Whereas a liquid, उन कुछ ढीला ढाला में से एक इधर है तो एक उधर है. no shape, no size. They are free to move because there is no attraction, no forces of attraction. So that take in the shape, मतलब उनको कहीं भी fit करो, they will be get fitted, they will be happy with that particular. So solid, liquid and gases, this is a major difference. Remember, forces of attraction play a very important role in molding the structure solid, liquid as well as gases. Now coming over to the gas, which is our topic of discussion. So for gas molecule, यहाँ पे मैंने आपको ऐसे दो ही बताए, दो तीन molecule बताए. Now in your book, in your it is on page number 122. Page number 122, open karo, keep your pen pencil with you. The first fact is given the state of matter interparticulate attraction is weak. Correct hai? Attraction is weak and the interparticulate space is large as compared to gas. So space is large. हम जो intermolecular bond है ना, intermolecular means between two molecules. This space is large as compared to this, as compared to this. If you want, you can take down this small figure ना. देखने के साथ में तुरंत आपको समझ में आ जाएगा. ऊपर नोटबुक में या आपके वॉल्यूम में you can make that small figure है. देखने के साथ immediately समझ में आ जाएगा. Instead of making this 3, you can make only 2 molecules. It will also do. हाँ, लेकिन उधर जगह उतना चाहिए कि you can make that 2 molecules. हाँ, पहले एक molecule में ही तो satisfaction कर लेगा. Don't do that. हो गया? अभी यहाँ पे देखो. In the beginning, I told that I have taken this cube. In this cube, I have solid, liquid, and gases. Okay, molecule भी मैंने थोड़ा reduce कर दिया. तो in order to show that this gas molecule they have complete freedom. Okay, now this container, this cube, it contains this many of ion number of ion molecules, gas molecule. They are free to move. They are free to move. वो कहीं भी जा सकते थे. परफ्यूम का बॉटल यहाँ पे अगर मैंने स्प्रे कर दिया तो उस कॉर्नर में भी स्मेल आएगा. That smell it is go in that room also. It will go out also. This means what? They are free. They are free to move. And when they are moving, it may happen they may collide with each other. Chances है. They may collide with the wall of the container. मतलब इसे स्प्रे मारने के बाद में ऐसा गिर के पड़ के ऐसे आके इधर भी टकरा जाएगा, है ना? वो एक दूसरे से भी टकरा जाएगा. So these are the various chances and this motion it is known as kinetic energy. Kinetic motion. Two types of motion we have. Two types of energy we have. Potential energy, kinetic energy. Potential energy it is for the body at rest. For example, that duster is at rest. This book, this pen marker is at rest. So it will be related with the potential energy. And when body is in motion, okay, चल रहा है, फिर रहा है, फैन घूम रहा है, तो it contain kinetic energy. Remember this two terms, huh? Then, अब उसने क्या बोला है? No matter which gas is taken here, no matter what is the color of the gas, but it is a gas. It is having freedom. It will move. It will collide. It will dash on the wall of the container. सब कुछ कर देंगे उनको कोई आ सकती है. Okay. Next point देखो. Kinetic theory of gas state that gas is made up of molecules which are random motion. Okay, random motion anywhere. They can move anywhere. Anyhow they can move. Now, few years back now, for 10th standard board, 12th standard board, name list आता था, हाँ, seat number वाला, और उसमें जो नाम होते थे, numbers, you can say seat number, they were according to the alphabetic order of first. In few cases, alphabetic order of the servant. तो हमको पता है, for example, अभी हम लोग एक क्लास के बच्चे था, पता है ना, ये बच्चा भी आगे पीछे हो जाए, right ना? But this is not happening now. Names are randomly, numbers are random according to the name. देखो अपन इसे जब आएगा ना तो random motion means can call it as a butterfly motion. This is circular motion. Okay, so random motion. And the thing explain the relation between pressure and volume and temperature. These three things are very important. Pressure, volume, temperature of the gas. Pressure, volume, and temperature. They are playing hero role in the life of gas. Pressure, volume, and temperature. Okay. Pressure means either it may be internal pressure inside that container or it may be external pressure which we are applying from outside. Volume, amount of gas which is taken in that particular container. Temperature, whatever is a temperature, you may increase the temperature also. Okay, it may be your exothermic, endothermic reaction if you are doing any preparation reaction. Okay, so pressure may be internal, external, volume, it is a volume of the gas. So we have to see what effect is there if you increase the pressure on volume. If you decrease the pressure on volume. क्या करना है हमको यहाँ पे पढ़ना क्या है इसके अंदर? What happens when if there is increase in the pressure? Increase in the pressure, what change will be there in volume? Similarly, if you decrease the pressure, what change is there in the volume? Volume बढ़ रहा है, कम हो रहा है, उतना है. Similarly, what happens if you change the temperature? Whether there is any change? In short, we are studying correlation of this thing or we are studying correlation of this thing. In some reaction, any one will be constant. Either this will be constant or this will. इतना आपको समझ में आया? कोई डाउट नहीं है? Sure. So under gas, what exactly we will focus? Pressure, volume, and temperature. We have to check if you are increasing the pressure, whether there is increase in the volume or not. If you are increasing the temperature, there is change in the volume or not. ये आपको करना है. हाँ, pressure it may be internal pressure or it may be external pressure. अभी next क्या? Kinetic molecular theory of gas. In short, it is given KMT. जो दिया है आपके बुक में, you will find it somewhere. KMT, kinetic molecular theory of gas. KMT. कर लो, all alphabets are capital, ना? KMT. Now, instead of taking that small container, here I am taking a cylinder. This is a cylinder. This cylinder, it is fitted with one movable lid. Movable lid, huh? So this is movable lid. मेरा फिगर क्या बोलते हैं, मेरा ड्राइंग इट इज वेरी गुड. शांति इज अवेयर ऑफ दैट. Okay, so this is a cylinder. This cylinder contains gas. So this cylinder it is filled with some gas. Okay, here we have movable piston. ये जो ढक्कन है ना, normally we are putting here lid, but इसको ऐसे फॉर्म किया है कि ये ऊपर नीचे मूव हो सकता है. So this is movable lid.
क्वेश्चन है
क्या?
इंजन का बताए.
ये समझो, समझने के लिए बताया क्योंकि हमको बहुत सारे पॉइंट्स इसमें पढ़ने हैं ना, इसलिए मैं. ओके, now in our point number 1 it is given composition of the gas. Composition of the gas. Now in the composition of the gas, For example, I have taken here hydrogen gas. हाइड्रोजन गैस तो हमने तो बहुत पहले पढ़ा है आपकी बुक में इट इज देयर ना मैटर इट इज मेड अप ऑफ एटम दिस atoms are the tiny particles under Dalton theory you have studied all this okay so for example these are my tiny छोटे छोटे से particles for example ना this is first one ऐसे बता दियो एरो वाला क्योंकि I have to show motion also so this is the second one randomly it is moving anywhere and there is one reason of using these markers कलर वाले मार्कर ने तो मैं खाली ब्लैक से बना के छोड़ दूं okay now first one composition of the gases in this see here this is my cylinder which is fitted with movable piston for example I said it contains hydrogen gas okay in class 9 or I don't know in your for you it is in which class but normally for CBSE Dalton theory it is in 9th आपको कहाँ पे है 8 में के 9 में देखा था मुझे so it contains tiny particles of the same gas जिसको हम एटम बोल रहे हैं okay now here as I have said I have made this by black blue color marker reason is that whatever the property this hydrogen atom is showing it is same for this one or different
same,
for this one
same.
so when you have only one type of gas the property of the tiny particles which are present in that gas it will be similar but if you are going with a different type of gas properties will be same or different समझ में आया ना अभी हमारे पास में दो बच्चे ये उतना ही लिमिटेड बोलता है एक हमारे पास में नॉन स्टॉप okay both are boys both are from same class may or may not be from same school but this habit it is different okay so here the tiny particles which are present which are of same gas they will show the same but in comparison if you have any other gas इसके साथ में दूसरा और एक पिस्टन लगा दिया सिलेंडर लगा दिया if you fill it with a nitrogen gas then it will show different chemical property physical property okay this is a one part वहां पे देखो पॉइंट में आपके molecules are small in size as compared to the volume of the gas correct na because we are saying the tiny particles are moving randomly in all direction they are moving randomly in all possible direction सारे direction बना देना you can show the upward direction also upward you can show the downward because it is in the random motion then the next one gas have neither a fixed volume or the fixed shape correct this we have done under properties of gas right now अगर मैंने इसको इसमें रखा है for example if I am taking in this cylinder which is rectangular in shape it will take the shape of that cylinder ज्यादा दूर मत जाओ for the perfume bottles we have different shapes छोटा रहता है बड़ा रहता है आप अच्छा वाला ब्रांडेड वाला लोगे तो उसका शेप फ्लावर शेप में मिलेगा पीकॉक शेप में मिलेगा बॉटल का अलग अलग शेप रहता है ना बट उसको स्प्रे करके जब वो बाहर निकल जाता है वो शेपलेस हो जाता है जो चाहिए उसको वो शेप मिल जाता है ओके नाउ इफ दिस गैस इफ आई फिल इन दिस सर्कल बलून में डाल दूं बलून का शेप ले लेगा if I put in the square it will take shape of that square if I fit this gas in the triangle it will go in that format if I place in the hexagon then it will take the hexagonal shape right so volume and shape is not fixed अब एक चीज मुझे बता मैंने तो आपको बता दिया वॉल्यूम एंड शेप इज नॉट फिक्स्ड वॉल्यूम का क्यों ऐसे बताया शेप का तो मुझे समझ में आया why it is about volume because we are taking fixed amount then why it is said volume it is fixed neither yes neither a fixed volume not a fixed
उनके पार्टिकल्स के बीच में अट्रैक्शन फोर्स नहीं है तो वो जितना दूर जा सकते हैं तो उसका वॉल्यूम भी एक्सपेंड होगा
But if I have, for example, if I have 5 ml by volume, if I have 5 ml of liquid nitrogen, okay, तो उसका वॉल्यूम फिक्स क्यों नहीं है?
हम उसका इंटरमोलिकुलर फोर्स थोड़ा ज्यादा है तो अपना वो उसका चेन को ब्रेक करके स्किन में कर सकता
ठीक है, मैं पूछ रही हूँ,
है।
आप बताइए, दिस इज योर आंसर। शांति, सेम आंसर। शेप का तो हमको समझ में आ है ना, मुझे शेप का समझ में, वॉल्यूम वाला क्या चीज होगा, थोड़ा दिमाग लगा दो, व्हाट अबाउट वॉल्यूम? इस रीजन जो इसने बोला ध्रुव, दक्ष और ध्रुव
और भी लक्ष्य
तो आपका सरनेम क्या है? दक्ष, दक्ष गुरु, is your name ना दक्ष गुरु, and his name दक्ष, चलो okay fine, volume or shapes, okay I understood, what about volume? Here I told you, with respect to temperature, we will see change in the volume, whether it is increasing or decreasing. With respect to pressure, we will find change in the volume, whether it is increasing or decreasing. ये मैंने आपको बताया ना, स्टार्टिंग में ही बताया था ना, आपने मुझे पूछा ये वाला कंटेनर क्यों लिया, ये कौन सी चीज का कंटेनर बताया आपने मुझे, कुछ तो बोला था ना, ऑटोमोबाइल क्या बोला था, इंजन वाला, ये वाला क्यों लिया, तो मैंने कहा देयर इज वन चीज, ये मैंने आपको आंसर, ओके, अभी मेरे आंसर देने की बारी आती है, ये मैं निकालती हूँ, everything I am doing, shape वाला part, we are clear with this part, we are on volume वाला. Now this cylinder which contain gas, okay, if I increase the pressure, if I increase the external pressure, मतलब इसको मैंने ऊपर से प्रेस कर दिया, हाँ, your initial volume is this one, initial volume, for example this is I, initial volume, मैंने ऊपर से I have applied external pressure, so what will be the position of this piston, it will be same or it will change, कहाँ जाएगा, downward direction, so for example this is going in this direction, चलो ये मेरा F हो गया, F हो गया, now when I am pressing it, I am bringing this molecule closer, there is a decrease in the volume, समझा, sure, okay, पक्का है ना,
हाँ मेरे को डाउट है,
इससे मैं रुकी हूँ, मुझे पता है, समझ में आया,
प्रेशर हम लोग दे रहे तो नीचे जाए, पर उनका तो फोर्स ऑफ अट्रैक्शन भी वीक है और उनका स्पेस भी ज्यादा है, तो वो कंप्रेस नहीं हो सकते
होंगे ना,
अब तो प्रेशर देना
gases,
पड़ेगा,
gases with more pressure na, they are compressed and they are converted into liquid, है ना,
तो वही आप वही एक्सप्लेन कर लो,
हम नहीं, मैं आपको बता रही हूँ कि neither volume nor shape, ये जो बताया है ना, shape का तो हमको समझ में आया, so how volume is changing, why it is not fixed, पॉइंट ये है,
हाँ प्रेशर
समझ में आया ना, एक पॉइंट हो गया, स्टिल वन मोर भी, समझे ना, अच्छा नेटवर्क,
हाँ प्रेशर
hydrogen and that previous one periodic table,
तो प्रेशर इंक्रीजिंग मतलब वॉल्यूम,
अभी एक ब्रेक है, it is for 15 minutes I think,
5
5 minutes definitely right, then we will complete that.
तेरे पास ये था तो बोला ही नहीं लक्ष्य के लिए
क्या
सर ने
क्लास
अरे टीचर अभी भी चल रहे हैं आवाज नहीं आ रहा संडे दिन आता है ना तेरा आवाज जी बार बार मुझसे ले रहे स्वेट मिक्स में आ रही है हमने बस करी ये पब्लिक को समझ में आता है ना कॉन्सेप्ट नहीं है इधर कोई कुछ नहीं है अरे ये होता है ना वाटर लॉगिंग फ्लैट्स पानी बारिश हो रहा है हाँ क्या इसको बोला घूमने का कोई ऐसे भी भेज रहे हैं रीगन कॉल में तो वो है रीगन कॉल में तो शी ऑर्डर मोस्ट अच्छा इतना सब किया गया उसने मैं इतना नहीं कर चाहता देखो इसका भी सीएफ रह जाएगा क्लोज फ्रेंड्स मेरे को भी हाँ ये बात मेरे को भी खाने नहीं ओके चॉकलेट एक छोड़ो ये क्या है सी ऑर्डर सी ऑर्डर उसके लिए so the explanation will be just 364 two ways that
Okay. One case we have done with the pressure. So if P external, it is greater than P internal. What happens? Position of piston
down
down. Piston go in the downward direction and volume decreases. Okay. So volume decreases. Now if P external, it is smaller than P internal. क्या होगा?
volume increase होगा और वो piston
Volume, there will be increase in the volume. Okay, and if P external, it is equal to P internal. Any change in the position of piston? Both are at the same pressure. Understood now? This thing is clear. चलो जाते. So this is how pressure affect the volume. Now moving to the next one for temperature. For temperature. Now as we know, these molecules they are moving randomly. They are moving randomly. Okay. So if you are increasing the temperature, what happened? If you are increasing the temperature, this molecules get more energy, more kinetic energy. And more kinetic energy means what?
Start faster.
फास्टर 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 वो होंगे तो यहाँ पे कोलाइड करेंगे, यहाँ पे कोलाइड करेंगे, सब यहाँ पे कोलाइड करेंगे and automatically what happened, they will collide with this part also, they will stack on this surface, piston वाले surface पे अंदर वाले पे, so there will be more pressure and due to this pressure what happens, due to this pressure volume बढ़ जाएगा. So if you are increasing the temperature, if you are increasing, then automatically volume it will increase. Volume increase. Okay. If you are decreasing the temperature, पहले तो वो गैस है. Decrease करोगे, खाली मोशन होगा और कुछ नहीं. Now see these 2 points. ये मैंने लिख के ही रखे आपके लिए. प्रेशर लेस है यहाँ पे टेम्परेचर इज दिस इज कंप्लीट वन. एक्सटर्नल प्रेशर इज लेस, वॉल्यूम इंक्रीजेस. टेम्परेचर इंक्रीजेस, वॉल्यूम इंक्रीजेस. सो इन शॉर्ट, increase in the temperature, decrease in the pressure. There will be increase in the volume. समझ में ले रहे हो आप? ये दोनों these two are enemies of each other. One increases, other decreases. याद रखो, नोट डाउन करके रखो, enemies मत लिखना relation. Then, so point number 2 is clear now. Now third point. Gas exert pressure in all directions. इनको पता है, right now it exert pressure in all direction on the wall of the container, on the wall of this cylinder, everywhere, even on the lid from the inner part it will exert pressure. Then यहाँ पे देखो दिया, the molecule exert pressure and this pressure is same in all direction because at a given temperature the same number of gas molecules stacked against the wall of the container. ये तो आपको याद नहीं है. Next करते हैं. Gases are highly compressible and when they are compressed, by increasing the pressure and decreasing the temperature. So by increasing the pressure, the gas can be converted into liquid form also. देखो वो point दिया है क्या? So what we are doing then, when we are increasing the pressure, exactly what we are doing, we are bringing these molecules together. Right now we are bringing, so when we are bringing this molecule together, this means what? Solid gas, it is converted into liquid form. बराबर है ना, gas is converted into liquid form.
Last point है तो इस चीज का, ये सब का last point gases can be liquefied.
दिया है,
हाँ
कहाँ दिया? लास्ट में दिया है. तो ये हमको समझ में आ रहा है इससे. Then gases are highly expansible. They are expansible. है ना? Here only we have done with increase in the temperature, volume increases, right now. बराबर ना, so they are highly expansible. Then gas have low density. Why they have low density? Between these two gas molecules there is a distance, there is a big space, due to which they have low density. Okay, then gases have natural tendency to mix with another, to mix with one another. Okay, to mix with one another, and this property it is known as diffusion. इसको स्टार करो. Or this mixing, it is always a formation of homogeneous mixture. When you are mixing different gases, there will be formation of homogeneous mixture. For example, this air. Okay, can we see air? Can we say this is oxygen, this is hydrogen, this is nitrogen? नहीं, पहले तो हमको दिखाई नहीं दे रहा है. और अगर कंटेनर में भी पैक करके रख दिया ऐसा बलून बना के तो भी हमको नहीं दिखने वाला है. फर्स्ट थिंग. सेकंड थिंग, अगर देख लिया अपने साथ की आंख से कहीं से देख लिया तो we cannot identify this is gas, this gas contain hydrogen here or oxygen here. No, it is not possible because first thing, air it is a homogeneous mixture. All gases are present. They are in the uniform state. Okay. ऐसा नहीं कि वह हाइड्रोजन है तो बोलेगा नहीं नहीं मेरा व्हाइट कलर है. नाइट्रोजन है नहीं बाबा मेरा तो ग्रीन कलर है. ऐसे कोई ग्रीन कलर अपना बता रहा है. So they are homogeneous mixture form. And this property is mixing property, uniform mixing. It is known as diffusion. Many times this question is asked, define or what is diffusion. So underline it. Gas can be liquefied. है ना? And how it can be liquefied?
Cooling the particles and this.
Cooling nahi, by increasing the pressure. Only by increasing the pressure you can cool it. क्या करना है, मैंने थोड़ा ही प्रेशर ऊपर से बढ़ा दिया और मैं बढ़ाऊं फाइनली इफ इट इज हियर समवेयर ना then that complete gas it will be converted into the liquid form. So these are the some of the postulates or points features of kinetic molecular theory of gases. कुछ है इसमें, कुछ है ऐसा डिफिकल्ट याद रखने के जैसा? कुछ नहीं. Only if you have this picture also, na, you can explain all what I think. देखो अभी थोड़ा एक बार picture अच्छे से ये वाला देख के ले लो. This whatever we have done, okay? Then we will go for it. Take 5 minutes and read it. Read from there. If you want, you can take this picture. It is easy to understand, huh? This particular thing. You are in 10 and 7. Okay. अब तक के तुम लोग को ये तो चीज क्लियर हो गई है कि chemistry there are many hypotheses, there are many assumptions, many imagination. Okay. जो तुम एक्सपेक्ट कर रहे हो वहां से उससे कुछ दूसरा ही रिजल्ट निकलता है ना? दिस एक्सपेक्ट दिस देन और क्या वर्ड उसमें यूज करते हैं, ये बहुत सारे ऐसे टर्म्स है. फॉर एग्जांपल इफ यू आर स्टडीइंग दिस वन स्ट्रक्चर ऑफ एटम, these are the big drawbacks. So the new theory, ये सारी चीजें होती है ना. आपको फिजिक्स में बहुत ऐसे इमेजिनेशन करना है. केमिस्ट्री में कुछ और
हमको समझ नहीं आया वो theory का रहता तो भी सीखते हैं.
तो तुम करना है कुछ नहीं, फ्यूचर में वो गलती फिर से ना.
जो सही
तो
है
उसने इतना काम किया था तो वो कैसे याद रखो. उनका भी नाम को कहीं ना कहीं एप्रिसिएशन मिलना चाहिए ना. अगर एप्रिसिएशन नहीं मिलता तो इट इज ऑफ नो यूज. They work on that. अगर वो वर्क नहीं करते तो कहाँ हम यहाँ तक पहुँच सकते, right ना? But the simple thing the rice which we are making, it is normal rice. राइस को हम कैसे दाल के साथ में खा लेंगे, दही के साथ, करी के साथ, ग्रेवी के साथ, हर चीज के साथ। जो लेफ्ट ओवर राइस है उसी कभी कभी खीर भी बना लेते हैं, उसके पकौड़े भी बन जाते हैं। यहाँ तक तो ठीक, लेफ्ट ओवर राइस, इडली वगैरह में भी राइस यूज होता है। आपने कभी सुना है राजमा राइस पकौड़ा? नहीं सुना। मैं मेरा भी मुंह ऐसे खुल गया, राइस पकौड़ा ठीक है। तो मैंने देखा, तो एक है राजमा राइस पकौड़ा, rice cooked rice and rajma boiled rajma. They are mashed properly and they are then fried to make powder. So this is for rich. एक पहले राजमा पर से ली, तो फिर राजमा राइस पकौड़ा कैसे चलेगा सिस्टम, समझ में आया? बट बेसिक इज व्हाट, सेम लाइक दैट। बेसिक वाले को हम नहीं पूछ सकते, उसको पकौड़े के लिए हमको राजमा राइस पकौड़ा खाना, ऐसे अज्यूम करके आगे चल। ओके, अभी ये जो नेक्स्ट वाला पार्ट है ना, यहाँ से योर एक्चुअल थिंग्स आर स्टार्टिंग, वेयर यू विल लर्न द न्यू टर्म्स। ओके, बाकी का सारा थोड़ा एक्टिविटी आपका साइड में रखो, अगर हो गया है तो। कितना लिखेगा बेटा बुक में का जो सब तुम्हारे, दिस इज योर वॉल्यूम, नहीं था एवरीथिंग विद
नहीं वो एग्जैक्टली
नहीं लिखता है,
एग्जैक्टली नहीं लिखा मैंने बस।
तो दैट विल बी टाइटल। हो गया, ये वाला लिखो, क्योंकि ये सिंपल जो है ना, विद दैट पिक्चर आल्सो यू विल अंडरस्टैंड, ज्यादा जोर देना नहीं पड़ेगा। ओके, नाउ हियर इन दिस पार्ट, पेज नंबर 123, मॉलिक्यूलर मोशन। ओके, we are on the motion part, we are studying kinetic energy or kinetic molecular motion, KMT, relation of temperature, pressure and work, right? This three things we will be focusing under this topic. Already with the help of that scenario, I have explained you how these things are working, how they are correlated with each other. Okay, और मैंने आपको और एक चीज बताई कि if you are increasing the temperature, so if you increase the temperature, what is going to happen? Volume will increase. Okay, motion there will be in the more kinetic energy state and volume will be increased. Okay, now you assume for time being, if you are decreasing the temperature, what temperature decrease करके क्या molecules solution और उसमें kinetic energy होगा कुछ नहीं करने वाले, वो जैसे के वैसे ऐसे हीरो के जीरो बन के बैठे हैं, है ना? पहले तो बड़े हीरो थे, they were moving here and there, moving randomly, butterfly उनमें आ गया था। Okay, but the moment when the temperature decreases, there will be no motion. Right now, अब मुझे एक बात बताओ, when we have already assumed that gas, it contains tiny particles, they are always in the motion state. They are always in a kinetic energy state. So is it possible to keep that molecule in that particular steady state, kinetic energy potential वगैरह? Is it possible? ये हो सकता है? नहीं हो सकता ना, ये भी आपको व्याख्यान है। और ये टेम्परेचर जो है ना, that temperature is known as absolute zero temperature. Understood? So normal temperature that molecules are moving, listen here, at normal temperature molecules are moving. Okay, they are moving, they are in random motion, they are moving here and there. If we increase the temperature, there will be increase in the kinetic energy. Okay, volume from third side. But if you decrease the temperature, completely so that the molecules are not at all in the motion, कुछ नहीं motion करके उधर जम के फिक्स होके पेपर लगा के हीरो के सीरो बन गए. So that particular temperature, it is known as absolute temperature, and that temperature can be measured in which scale? Kelvins. Okay, so that point, it is point number second. This is third one. Different one. average kinetic energy of the molecule is directly proportional to the absolute temperature. What is absolute temperature? It's not given. Next. Now, if the temperature increases, this is another sentence. ये दोनों का relation हमको बाद में मिलेगा. If the temperature increases, molecular motion also increases. Agree with this point? And vice versa. So vice versa, if temperature increases, motion increases. If temperature decreases, motion decreases. This is the temperature, sorry. This if the temperature is zero, the molecular motion aces will stop. We apply this fact to the Kelvin scale, which is called absolute scale. So on this scale, when the motion aces will stop, is called absolute zero. थोड़ा सेंटेंस को डिफाइन किया है, but in simple terms, if you are decreasing the temperature, motion will stop. No kinetic energy. इसको मैंने assume वाला term में इसके लिए बताया है, because this is not possible in case of this. We have to assume that temperature is absolute zero. क्योंकि गैस है वो तो मोशन करेगा ही, उसका प्रॉपर्टी है डिफ्यूजन का. So is it possible to stop that particular process? Increase that temperature to that much height that there is no motion in the particle. नहीं possible है ना, जैसे कि आपके बोर्ड्स में वो एक पॉइंट था, बोर्ड्स में रुदरफोर्ड में इलेक्ट्रॉन is moving, it is having some kinetic energy. So with motion there will be decrease in the energy and finally electron will fall on the nucleus and atom will collapse. तो मैंने आपको क्वेश्चन क्या पूछा था, in that case it is possible to have a matter? No. Same thing is here. अगर गैस का टेम्परेचर 0 कर रहे हो तो मोशन में पार्टिकल्स नहीं है, तो गैस का प्रॉपर्टी क्या है? पार्टिकल्स आर इन मोशन. So this is one of the assumption we have to consider and move for the next. देखो भी नेक्स्ट में ही वो दिया हुआ है, पढ़ो क्या सेंटेंस है. The temperature at which
The temperature at which the volume of a hypothetical gas.
एक मिनट, hypothetical gas. It is real gas. It is real gas. No. Understood? हाँ, कैसे देखो, कैसे हमको पढ़ना पड़ रहा है. Hypothetical gas becomes zero. So it is only the assumption, there no molecular motion among its particle is called absolute zero temperature. This temperature is minus 273.15 degrees Celsius. Note down that. So at this temperature, what happens?
All particles
Stop moving. So no motion,
no kinetic.
no kinetic. Understood?
मेरे बोली से
Hypothetical gas.
तो ऐसे जब ऐसे होगा जीरो में तो प्रॉपर्टीज चेंज होगी और गैस नहीं रहेगा.
मेरा कोई पॉइंट है तो वो पहले ही किया है, पहले उन्होंने क्वालिफाई किया थी सारा गैस में रियल वन. शांति आगे जाएंगे. दिस पार्ट इट इज क्लियर ना, नो डाउट ना. अगर नहीं समझ में आ रहा तो पूछ लो, बिकॉज जो आगे जैसे जाओगे ना डिफिकल्टी लेवल इज जो हमें नहीं समझ रहा रुक जाओ. एनीवेज वी हैड टाइम सफिशिएंट टाइम. आवर फ्रेंड्स आर एब्सेंट और शांति ऑल आर एब्सेंट. चलो आगे जाओ. When a gas is enclosed in a vessel, particle exert uniform pressure on the wall, right, of the container. This is because the particles of the enclosed gas collide with each other and even with the wall of the container. Correct? Because of this, large force is experienced on the wall of the container, right? The pressure of the gas is this force that exert on the unit area on the wall of the vessel. बहुत लंबा चौड़ा करके था. मैंने तो internal pressure, I have used this term.
Internal pressure.
This is the internal pressure. And how this internal pressure is created? That molecules which are present, they are exerting certain type of force. Okay? That force per unit area on the wall of the container is known as your pressure. Okay? वैसे pressure का mathematical expression क्या है pressure का? Pressure is equal to
Force upon area.
force upon area, or we can say force upon displacement. Area wise displacement होता है ना, so pressure is equal to force upon displacement I have written, or you can call it area. अभी यहाँ पे देखो in this equation, pressure is equal to force upon area or displacement. Physics में आपको दोनों पे चीजें मिलेगी. Now what is the relation of this thing? Pressure increases.
When force increases.
When force increases, there will be increase in the pressure. Okay, internal pressure. We know what happens when internal pressure increases. Then what about the area?
Increases.
Area decreases. वहां पे उस साइड में if you decrease the pressure, then decrease the force, pressure decreases. This relation, remember, pressure is equal to force upon displacement. चलो आगे चलो. Next. उसको प्रेशर का डेफिनेशन है ना, उसको लिख लेते हैं अंडरलाइन. It is just we go above that last bullet. Okay. अभी next है. If you keep the volume constant, but increase the temperature, what happens if you increase the temperature? वो पता है ना?
Speed बढ़ेगा.
हाँ, और क्या हो जाएगा? बढ़ जाएगा और finally there will be increase in the volume. Let us see what is here. If you volume stay constant but increase the temperature of the gas, average kinetic energy of the gas increases. Kinetic energy increases, and therefore average speed of the gas also increases. Speed of the gas increases. फिर मतलब कौन सा colliding वाला speed. Now the particle of the gas strike the wall of the container, correct? With greater momentum, and the nature of collision also increases. पहले एक बार टकरा गया था, but due to high temperature now it will collide 2 times, 3 times. Thus overall force exerted on the wall increases, which result in increase in the pressure of gas, correct? If the wall of the container are pushed back due to increase in the pressure, the gas expands. इतना घुमाया है देख. इतना घुमा के देख लिया है. Gas expand and how it can be indicated by with that piston. It will move in the upward direction. Understood? समझ में आया? मैंने मोटर गाड़ी का क्या इंजन क्यों बनाया? अभी तुझे मोटर गाड़ी का इंजन याद रहेगा ना? With motor गाड़ी का engine you can explain your kinetic theory, you can explain your relations also.
यही है that's it. प्रेशर अंदर डिक्रीज हो जाए तो वापस पीछे जा रहा है.
आपके टीचर ने सेम ही
आप फिजिक्स में बताया था.
So same thing we are using for ions. अभी से क्लियर हो जाएगा तो फिर ठीक है ना, आगे वाला चीज हमको इजी हो जाएगा. Obsolete zero is for which gas? It is not a real gas. हाँ, सारा प्रॉपर्टी का सत्यानाश करवा दोगे. Okay, done. Next. अभी हम जाएंगे हमारे लॉस की तरफ. आपके सिलेबस में की लॉस आर गिवन. The first sentence under the gas laws is the laws that govern the behavior of the gas when subjected to change in pressure, volume of temperature are called gas. Right from beginning the same thing I'm saying we have to study gas law with respect to pressure, temperature and so wherever it is applicable for whichever gas that particular gas is obeying gas law. Gases सारे gases के तीनों पैरामीटर नहीं एक्सेप्ट है. जो करेंगे वो गैस लॉ के अंदर आता है. तो इसमें फर्स्ट कहते हैं 3 variables pressure, temperature, volume we know. All gases are similar in physical behavior. Okay, motion वाला physical behavior and under the same condition will expand or contract equally. Right now, same condition मतलब increasing the pressure, external pressure, increasing the temperature. So all gases they will behave like same. Same. Okay. किसी भी गैस को सिलेंडर में रखो, increase the external pressure automatically piston will move the down. कोई गैस नाटक नखरा नहीं करेगी कि प्रेशर क्यों बढ़ा है. हाँ, वो नीचे की तरफ ही जाएगी, वॉल्यूम उसका रिड्यूस ही होने वाला है. If I increasing the temperature, automatically there will be more kinetic energy and volume of the gas will increase. Okay, वो गैस ऐसा नहीं करेगी कि टेम्परेचर क्यों बढ़ा है, मेरा बहुत मोशन यहाँ पे हो रहा है, मेरा एनर्जी बहुत वेस्ट हो रहा है ना. So whatever things are there for any of the gas, they are safe for any gas होती है. हाइपोथेटिकल को हटा के अब कोई भी गैस ले लो, same principle they will follow. Now the first one, because they have given this one definition for pressure, temperature with unit, and then they have explained gases. The first one is for volume. Okay, so volume, how we measure volume? What is unit for volume? Centimeter cube. Centimeter cube. Oh, समझ में आया कि सेंटीमीटर. मैं सेंटीमीटर को अलग करो, क्यूब को अलग करो, ये कैसे यूनिट हो? Okay, चलो. The volume of the gas is a space occupied by the fixed mass of the gas. That space is also the volume of the gas. So whatever the space that gas is occupying, it is nothing but volume of the gas. हाँ, कुछ भी जो भी space को occupy कर रहा है. For example, there are many experiments for hydrogen gas detection. 10 standard में भी है. हाँ, next year को पता चलेगा. So once you collect that gas, you can identify by using litmus paper test the volume हो गया है उसका. और by there are experiments where the lighter gas are collected above water. ऐसे वाले भी है. So if you have take 10 standard textbook now or any of my friends there in 10 standard, just go to the textbook, you will understand. तो पहला क्या है? Space occupied by the gas, it is nothing but volume. Then second, SI unit. SI unit was seen here after this. Remember all units because these units are very important. SI unit is cubic meter. M small and Q. Its smaller units are. So apart from this cubic meter, the smallest unit is cubic centimeter, millimeter, milliliter, ml, then cubic decimeter, which is dm3, cubic meters decimeter. Then the relation between this relation is important because they are asking a problem based on conversion. So 1 meter cube or 1 cubic meter is equal to 1000 cubic decimeter, which is equal to 1000 liters. 1000 liters. Then 1 liter it is equal to
1 cubic is
1 cubic deciliter, which is equal to 1000 ml, which is equal to 1000 cm cubic centimeter. Okay, put relation that, write down that relation in your notebook. For conversion, you may have this one up. Normally for practical work, we are using 1 liter is equal to 1 cubic deciliter. But आपको problem solve करने के लिए आना चाहिए. चलो. So this one volume concept is clear. Next pressure. Pressure तो हमने वहाँ पे भी देखा था. Pressure is equal to force upon area. Right now, let us go for this part. Force that gas exert per unit area on the wall of the container. Same thing which is given here. Now see. Example बता रहे. Our earth is surrounded by the air called atmosphere and the pressure exerted by this air is called atmospheric pressure. बराबर है? The pressure is defined as a pressure exerted by 76 centimeter mercury at 0 degrees Celsius and standard gravity 9.6 meter second raised to minus 2. The SI unit of pressure is Pascal. Scientist का नाम. काम किया तो नाम तो आना चाहिए. It will be remembered always. Pascal is defined as pressure exerted when force of 1 Newton. Newton बताना पड़ेगा ना. Act on an area of 1 meters. Newton meter square. The conversion units then unit for pressure. So first unit is Pascal, another unit is atmosphere, torque, which is also one unit, but normally we are using Pascal or atmosphere. In centimeter, in millimeter, in torricilia, then relation between unit, the last one, 1 atmosphere, 76 centimeters mercury, 760 mm of mercury, and which is equal to 760 EO double RB है हाँ, EO double R. So this last two points are very much important. बाकी का तो आपको याद रहेगा Pascal and atmosphere, it is not so big. Then next one, temperature. Temperature, how you will define temperature? क्योंकि आप आइस का भी टेम्परेचर देख सकते हैं, हम बॉइलिंग वाटर का भी देख सकते हैं. You can check temperature of water, you can check temperature of steamers. Okay, तो हम लोग खाली ऐसे भी बोल सकते हैं इस hotness, is coldness or coldness, the degree of hotness or coldness, and which states units are used to check the temperature.
Celsius.
Celsius, Fahrenheit, and Kelvin. 3 units are there. Let us see what is given here. Degree of hotness of the gas. Okay, but normal temperature is hotness or coldness. Remember this है. आपके यहाँ पे ऐसे दिया. मेरे टेक्स्ट में क्या दिया है? Only the hotness or both things are there. It should be hotness or coldness. Definition is not given.
Increase.
No, it's not given. And density, temperature, units are given. Not given. anyways हमको तो पता है कि किस measure of hardness or coldness or degree of hardness. Whatever I have shown you with respect to that cylinder in the sea. Same thing it is given here with the help of graphs. Same चीज है. लेकिन अगर आपको वो वाला concept it is clear ना, you can without looking just say you can explain. चलो आते हैं temperature वाले पे. Temperature is degree of hotness or coldness. The scale used for noting the temperature of the gas is Celsius scale, which is called centigrade. The 0 on Kelvin scale corresponds to this. On the Celsius scale, 0 on Kelvin scale. Okay? And the relation of Kelvin and Celsius is Kelvin is equal to degree Celsius plus 273. अब यहाँ पे थोड़ा सा चेंज कर दो. Kelvin में if temperature is given in Celsius, we can convert it into Kelvin. If it is given in Celsius, you can convert it into Kelvin. By adding to it. Okay, similarly by rearranging the same equation, you can convert it into Celsius. कैसे हो जाएगा वो? Celsius is equal to Kelvin minus 273 बराबर है minus 273. अब यहाँ पे देखो the 0 on the Kelvin scale corresponds to 273.50. ये वाला पॉइंट नहीं रखा है, लेकिन आपके कन्वर्जन ही आ जाए. नेक्स्ट वन pressure and volume relation. Relation. What is relation between pressure and volume? Just now we have this. Now, here we are on the laws. The first law is a Boyle's law. It gives relation between pressure and volume. As such, we have already done it. We know what is the relation. If pressure increases, volume decreases. ये same चीज Boyle's ने किया था. It is known as Boyle's. So the relation between pressure and volume is direct or inverse. ये सब पहले वाले को डिस्कस करा. इनवर्स ही है. वो खाली उन लोग को करके पढ़ो. Pressure is equal to force upon area. है ना? So Boyle's, he has given the law known as Boyle's law. For this one, he has given the relation between pressure and volume. Now, according to the law, pressure, it is inversely proportional to 1. बराबर है? Pressure is inversely proportional 1/V to the volume at constant temperature. We are not changing the temperature. Temperature is constant because we know these two are the enemies. अगर ज्यादा गड़बड़ किया तो यहाँ पे पूरा गड़बड़ हो जाएगा, तो इसको हम constant ही रखते हैं. Pressure is inversely proportional to volume. Now here we have proportionality sign. According to mathematical laws and principle, in order to remove this sign, we have to take a constant. बराबर है ना? So here I can have P is equal to K upon V. नहीं, constant. Okay, I have removed this proportionality sign, na? As it will K into 1 upon V. Just I have removed this sign. Done. Next step, I can rearrange this equation. I can rearrange this equation for K. So my equation becomes PV is equal to Q. बराबर है? बराबर है? So at constant temperature PV product it is always constant. This is also proportionality constant, na? So this product value it will remain constant when temperature is constant. This is given by Boyce. अभी ये तो आपको बुक में लिखना पड़ेगा. आपके नोटबुक में राइट डाउन हेडिंग, राइट हेडिंग, Boyle's law. Write down that statement also. BOY L E apostrophe S. BOY L E S. Boyle's law. From here, your 10th standard, your 11th standard, 12th standard, entrance, everything start from your Boyle's. Here, done. Statement. Write on that statement. The volume of the given mass of the gas is inversely proportional to its pressure at constant temperature. Done. Then derivation is given according to the law. Now here they have taken P is proportional to 1 upon V. मैंने इसको बनाया है P is proportional to 1 upon V. Meaning this one and the same because this two are inverse relation. So either you go by this method or you can go by that method or you can follow your textbook. Your textbook में क्या है?
मैं लोग ने दो केसेस लिए.
हम रहने देना, भी करेंगे. ये भी अच्छा textbook में. ये मुझे सिर्फ क्या पूछना है T को लिया है या V अपन दो करने में 10 करने में हम भी करेंगे ये इस ओके उन्होंने P V लेके लिखा so you also go with V is proportional to 1 upon P. Next line make the changes according to that. V is equal to K 1 upon P, that is PV is equal to K. बराबर है ना remaining part will be same. PV is equal to K is equal to constant. This volume is from that side.
ये चलो है बेस अंदर
ये क्या होता है?
एक्स्ट्रा प्रैक्टिस सेशन.
इससे इतना होगा मतलब
सास हम लोग पूरा क्लास साथ में बैठ के उनको प्रूफ दिया जाता है. टीचर से फ्लोर से सुपरवाइजर और एक सेशन.
okay so next thing. Now let's particular mass of the gas occupied if the particular mass of the gas occupies. So it is actually more than one case. So your condition is given. First one, volume V1 at temperature P1, volume V2 at pressure P2. According to Boyle's law, P1 V1 is equal to P2 V2 is equal to constant at T constant. अब जैसे मैंने आपको बताया है कि PV is a constant, if the product of P and V is equal to constant, ये बोला है ना तो constant term के it is a constant right now. We have another way of defining right now. temperature remaining constant. This is another way of defining voids. Temperature remaining constant, which is not given in your book, but remaining here. Which is again the product of volume and pressure, product of volume and pressure of given mass of dry gas, given mass of the dry gas is constant. Given mass of the dry gas is constant. Okay, now in your book, problem is solved. Let us have one problem. छोटा सा ज़्यादा कॉम्प्लिकेटेड नहीं करेंगे. We will take from this value always. Volume of the certain amount of the gas 25 degrees Celsius and 100 cm Hg pressure is 80 mm. Volume is given. The gas is expanded to 160 mm. So from V1 it is expanded to V2. Keeping the temperature constant. So only for boils the temperature is constant. Calculate the pressure of the expanded gas. This means we have to calculate P2. P1 it is given in the problem. P1 is given in the problem. So first write down all the given things. P1, B1, then P2 and B2. बता दो कुछ values.
P1 100 centimeter mercury.
P1 100 cm Hg. Then B1
80 mm.
80 mm. Then P2 we have to calculate and B2
P2 160 mm.
160 mm. This is in ml, this is in ml. Hg, Cl Hg, this we have to calculate. Now one more data it is given that T is constant. So T is constant in only and only in Boyle's law. So next step, P1, V1 is equal to P2, V2. This is equal to constant, right now? So P1 value it is 100 cm Hg into V1 80 ml, which is equal to this P2 we have to calculate into 160 ml, right? Then rearrange this equation for P2. P2 therefore P2 is equal to 100 cm Hg into 80 ml divided by 160 ml. This ml get cancel 1 and 2. वहाँ पे ऐसा कचरा मत करना, हाँ. Literally you will not believe students are doing this much of crossing here and here. This you can cross out with pencil. Later on, write down the final answer. 1 and 2. So this will be 1 and 50, right? Answer is 50 cm Hg. Check करो. सही है ना? उसमें कुछ है ही नहीं डिफिकल्ट. इस प्रॉब्लम में दम ही नहीं है. Let us have the next one. Yeah, चलो. क्वेश्चन पढ़ ले. You are having वॉल्यूम का कॉपी मत करो. थर्ड टाइम के लिए वॉल्यूम मत करो. मैथ्स का पार्ट भी तो आना चाहिए आप लोग. वॉल्यूम मत करो ना, मैं बता रही हूँ. Listen carefully. At particular, a certain quantity of gas occupies a volume of 74 cm cubic centimeter. 74 cubic centimeter at a pressure of 760 mm. हो गया? Full stop. If the pressure is decreased, if the pressure is decreased to 740 mm, what will be the volume of gas at the same temperature? Same temperature, na? Temperature is constant, right? Here it is not mentioned, it is constant. They are making you fool here. But when temperature is constant, no doubt it is constant. First write down the given things. P1, P2, V1, P2, KKN 72. Then write down your formula which you are going to use, substitute the values and rearrange. Otherwise, you can rearrange it first and then do substitution. It is up to you. Copy मत करो बस इतना ही काम. Formula is क्या है? Answer you are saying? Answer is 76 unit. हाँ, half marks cut. Unit. बताया ना? Enter the values per unit. कितना आ रहा है यूनिट? यूनिट क्यूबिक सेंटीमीटर. पहले क्यूबिक दिया है, अदरवाइज वी कैन कॉल इट एज सेंटीमीटर क्यूब. नॉर्मली वैसे ही करते हैं, बट हियर इट इज क्यूबिक सेंटीमीटर. क्यूबिक सेंटीमीटर. फॉलो योर टेक्स्ट. कितना टाइम लगेगा? टाइम लग रहा है अभी. बस वहाँ बारिश भी लग रही है. Yesterday it was nice, no rain. From tomorrow. So bad. So ऐसा लगता है कि पैर में कंप्लीट पानी के अंडर सफोकेशन. सेम थिंग इज हैपनिंग विद मुझे ये भी निकाल के रखेंगे. ओके चलो आ गया. कैसे करना है? First write down the given thing, the formula which you are going to use, rearrange that equation and then do the substitution. And for substitution, substitute with the unit. So common वाला unit you can immediately cancel. ऐसा गलती नहीं होगा, otherwise marks will be deducted. Okay, it will be your which reaction? Redox reaction. चलो दूसरा वाला करोगे ना प्रैक्टिस और प्रॉब्लम सॉल्व सेम करना है. PV P1 is equal to P2 basic scenario to constant. चलो आगे देखते हैं. यहाँ पे the same thing is given, हाँ. तो at two conditions है. Now graphical representation. The graphs are given here. One by one, page number 125. Page number 125. First graph is for V versus 1 upon P. Second graph is for V versus P. And third graph is for PV versus P. क्या difference है तीनों ग्राफ में? Look at those graphs carefully and then. Difference दिख रहा है? ऐसा देखिए जैसे दिख रहे हैं.
सब एक ही. लास्ट
तुम्हारे बुक में सारे एक ही जैसे ग्राफ से, मेरे बुक में अलग है.
लास्ट वाला अलग.
क्या है डिफरेंस? सो बता. टेम्परेचर
नहीं
This is one graph. This is I think second one. And
हमको क्लास में सिखा सारा वो करते हैं
नहीं सिखाते हैं।
नहीं आप हमको नहीं सिखा
देख लेते हैं क्या।
हाँ
So first graph, it is your voice graph. With increase in the pressure, there is decrease in the volume. हमको क्या देखना है? On y-axis there is volume, on x-axis there is 1/p. As per our law, with increase in the pressure, this is inversely proportional. बराबर है ना? So check whether it is inversely proportional or not.
हम दोनों तो बढ़ रहे हैं नहीं
वो देखने के लिए हमको ऐसा लग रहा है कि वो दोनों पढ़ रहा है। हाँ, लेकिन वो क्या है 1/p। तो ये जो प्लॉट्स होगा ना पॉइंट्स आएंगे वो ऐसे बैकवर्ड डायरेक्शन में आएंगे। They will not go in the forward direction. Okay, so if increase in the pressure, there may be decrease in the volume. बराबर हो गया ना? तो this graph when you plot a line, तो ये this line it will passing from the origin, straight line passing to the origin. So this is your first. Second one, P versus B versus P. B versus P. So for that, the temperature is again constant, and you will get a curve. Curve. वो curve कौन सा है? That curve is a hyperbola curve in first quadrant. Four quadrants are there ना? Positive, 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 negative, 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 positive. There will be hyperbola curve in the first. And the last one, very simple and easy, product of PV versus P. So if you have this value, it will be parallel to your x-axis, parallel to the pressure. इसमें नहीं दिया, आपके वॉल्यूम में नहीं दिया. Explanation of Boyle's law in terms of kinetic energy. So in terms of kinetic energy, means the same thing with increase in the pressure, with decrease in the pressure remain constant. What changes are taking place? Let us see. Same thing is there are different things are there. First one, kinetic theory of gas and number of particles present in the given volume of the gas is fast. The average kinetic energy is also fast. Okay, it is in general. If the volume of the given mass of the gas is K1, it is half, now then the same mass of the gas gave half the volume to move. क्या ये बोल रहा है? अगर if you are decreasing the volume of gas by half ही गैस बच गया. अभी वो जो हाफ गैस बचा है उसको वॉल्यूम कितना हो गया, मतलब कंटेनर का वॉल्यूम है, इट इज कंप्लीट डबल वॉल्यूम इट विल बी यूटिलाइजिंग कंटेनर का वॉल्यूम हम से ना. पानी का बोतल है आपके पास ट्रांसपेरेंट, आई वांट ट्रांसपेरेंट, आपके पास है कौन से? ये देख For example, this is my cylinder with the four molecules. वो घूमने फिरने के लिए इतना जगह है, हाँ इतना जगह है. From this floor, if I remove to volume is the same, है ना? Volume same है. I have removed 4. Now what about हाँ इसको घूमने फिरने के लिए इसका एरिया ज्यादा हो गया है ना, हाँ डबल हो गया ना. पहले जो हाफ में था अब वो डबल हो चुका.
डबल हुआ तो
काइनेटिक एनर्जी के उसको ज्यादा स्पेस
आपको बढ़ेगा.
तो ये वाला दिस थिंग विल बी टेकिंग नेक्स्ट पीरियड एंड वी विल स्टार्ट विद द नेक्स्ट ना. तो क्विक रिकैप एंड वी कंप्लीट द रिकैप एंड देन वी विल टेक
नेटोग्राफ
तो बात करें इस ग्राफ में ठीक है. मध्य ऑब्स्टिकल नहीं समझ रहे हैं ना, just you go with this cylinder, it is enough. बराबर है ना, इसलिए बोला है ना आपको सिलेंडर बना के लो, सिलेंडर बना के लो. चलो बाय, ऑल द बेस्ट, लेट अस मीट ऑन नेक्स्ट क्लास.
Your booking there, challenge to the rest.
मेरा से क्या नहीं दे